Likith Kumar Reddy from Masters in Data Science, and the project I'm working is predicting parole acceptance based on age, gender, offense, race, and sentence type. In this, I would like to speak about where I got the dataset from and the objective of the project, how I cleaned the dataset, what I did for EDA of the dataset, and the modeling of it. So the objective of it is to predict parole acceptance or decline based on the sentence type, age, gender, offense, race, and the sentence itself. So I got this dataset from Texas Department of Criminal Justice, and this is an on-hand inmate population with relevant demographic offense and parole information from the same Texas Department of Criminal Justice. So this dataset has 119,000 rows and 20 columns, while each row is one inmate record. So the key attributes of this dataset consists of many columns, which are many rows, which is the identification can be done using three of those, which is SID number, which stands for State Identity Number, TDCJ number, which is Texas Department Criminal Justice number, and the name as of the prisoner. So the current facility is where the inmate is housed as of now. The projected release date is when the inmate can be released out of the prison. Maximum sentence date is how long he is supposed to be as per the court of law. Parole eligibility date is when he or she can apply for his parole. Sentenced years. So the number of years that has been sentenced to him. So last parole decision, the decision that came out of his last parole hearing. Next parole review date is when he can face the parole board again. Parole review status is either accepted or denied based on his last parole decision. So I went ahead and did my cleaning of the dataset. So initially what I did was I dropped all the non-irrelevant columns from my dataset, which is TTCJ number, SID number, name, case number, and next parole review date. So the first four were dropped because they doesn't have any relevance to my work, and the next parole review date also doesn't give me any information which I'm looking for. After that, I went ahead and dropped all NaN values. So the parole eligibility date, last parole decision, parole review status, maximum sentence date. All these columns, whichever has NaN values, I dropped all of those. Post that, I replaced life sentence with the number 110 so that it is easier to work with. Then I went ahead and split last parole decision column into two columns, parole decision and parole decision date for easy working of data. Then I removed all the null values from my data set. So I did EDA for this, and I tried to find relation between each of those columns. In the EDA part, I looked at the top 10 offenses that has happened, top 10 facilities that are holding the inmates as of now, top 5 unsafe counties as per the data, parole approval and denial rates, acceptance of and denial frequency of parole based on age and sentence time. Also, parole decision based on gender and race. As per the plot, we can see that the data indicates murder tops the list while robbery takes the second place and sexual assault on minors comes in the last of the offenses. We can see that out of 5 unsafe counties, the first one is Harris and the second one is Travis. And to be frank, there is a huge disparity between the first one and the fifth one, which is a good thing. And as we can see, top 10 current facilities, they all hold almost similar number of inmates at any given point in time with some variance. Parole decision with regards to gender and race. As you can see in this one, the graph shows that males gender got uh, more approval and denial, while the female are a bit lower because of the inmate population. And it's also same with the race. When we take into consideration, there are three particular races that stand atop, and the rest are kind of low with our data. So when I come to modeling and evaluation, I did this project by using four modeling concepts. One is logistic regression model, second is decision tree model, and third one is KNN model and random forest model. So what I did with regards to modeling is I created numerical and categorical pipelines, then used simple uh, imputer to fill in null values, and I used median for numerical values, and I used most repeated values for the categorical values. Then I used train split to split my data set into training and training and test data sets. Then um, to compensate class imbalances in grid search, I used F1 underscore weighted as my scoring method. So this is the linear regression model and decision tree model reports and ROC curves. As we can see, in linear regression model, I did after the second sample, I got a C value of 5, and with that C value of 5, I got an accuracy of 84% and ROC uh, area under the curve as 0.723. And with regards to decision tree model, the maximum depth was like 15 and minimum split sample was 10, while the accuracy I got was 84% and the area under the ROC curve was 0.713. Going ahead, with regards to the KNN classification, for the initial one, when I did it, I got around 50, and so when I did it for the second time, I got a hyperparameter of 60 with an accuracy of 80% and ROC curve of 0.71 area. And finally, in the random forest model, um, I got an accuracy of 68% and area under the curve as 0.695. Um, when we compare all these four models, I see that logistic regression model and decision tree model gives me better accuracy over KNN classification and random forest models. Both logistic regression and regression model and decision tree model are similar with regards to the accuracy, whereas the KNN is slightly less by 4 points, but with regards to the random forest, I got a 12%, almost close to uh, 16% variance, which is not satisfactory when compared to the other models. So I would like to I prefer and I like I use linear regression model and decision tree model for the analysis of my project. Thank you very much.